So this, as it's written, is correct and fine. So if this was put into that box, it would say it's correct. It's generally weird to leave a negative in the denominator, so I would probably just move that negative. Oops, that's a negative. And I noticed some people also moved that whole x squared to the bottom, which would also be fine. So actually, any of these are correct.
It wasn't accepting the second answer, though. The -1 over 2x squared plus c. It was saying that it came out to like 4x to the third or something.
Did you have parentheses?
I tried it a couple different ways. I tried negative and then parentheses 1, and then I tried without the parentheses, and both times it came out to like 4 something. I don't know if I was doing all the annotations right, though.
Yeah, it might not have been right. So here I'm putting -1 on top and then divided by, and that whole 2x squared would need to be in parentheses to show that all of that is in the denominator.
Okay, that's what I didn't do. I didn't put those in parentheses. That makes sense.
Yeah, because if we don't have those parentheses, if I take that off here, now it's putting that over to the other side.
Okay.
So that is, yeah, we need that. And that should is correct.
Awesome. Thank you.
So since we don't use this software in this class for homeworks and stuff, it's it can be tricky to input it correctly. But okay, so as we know from all of our derivative doing in the last several weeks, we can have things that have less straightforward exponents. So this is where I was about to go off on a little tangent earlier, but now it's actually appropriate. So just like when we're doing derivatives, when we are doing integrals, we need to have everything set up to follow our rules. So we need, if we're using that reverse power rule, we need x to the n power. This first one here in this integral is already all set up. It's some constant times x to some power. The second one, though, needs to be rewritten so that that x to a power is being multiplied rather than divided.
So 3x to the -4.
Exactly. So that should be the first thing we do, is just to make sure everything is set up for our integration rules. The other,
well, go ahead. I was going to tell you what I got, but go ahead.
Okay, well, let's go through it because there's some tricky things about this one. So if we are using fractions in powers, that's a place where a lot of people get thrown off when we're doing integrals, and so it's important that you have a good understanding of operations with fractions. So in this first one, I'm just going to, in this first one, our n is 2/3. That's the power that's on the x. So n plus 1 is 5/3. 5/3, yes. So there's a few different ways to write this next part, but I just want to make a little note here. If we're doing our integral, the power is going to be raised by 1, so now we're going to have 5/3. And that whole thing is going to be divided by the new power, which is dividing by 5/3. So we need to remember that that's actually the same thing as doing 2 times 3/5 x to the 5/3. So it's not necessary to go through the dividing, although it might help just to follow the rule. But really, when we have a fraction as an exponent, when we do the dividing by the new exponent part, really we're doing multiplying by the reciprocal.
So would it be correct if we left it in the first format?
Now it needs to be simplified.
Okay.
You can go through that step, but it does need to be simplified, which will end up being 6/5 x to the 5/3. Or you can put the x on top if you want to.
Three x to the -3rd over a -3.
Right, exactly. So on that one, on that one, our power is not a fraction, so we can just add 1 to it. -4 plus 1 is -3, and divide by that, and the plus c. And here we have -3 cancels with -3. And so this answer is just fine. But we can also take that x to the -3 and put it back in the denominator where it started if we want to.
I'm sorry, Madeline. If we were to do that, if we were to simplify it even further, okay, you're gonna do it. I'm sorry, my computer was lagging.
That's okay. You know, delays in Zoom always cause some issues.
So we need to reduce that x to the -3.
You don't have to. Either of these would be fine.
Okay, but you just can't leave it in the 3x to the -3 over -3.
Right.
Okay.
Yeah. Fractions should always be reduced. Changing it from x to the -3rd to 1 over x to the 3. And neither of those is more simple necessarily. It just kind of depends on it's just a different notation. So we do need to be careful with those fractions. It's following the exact same rule, but it's easy to make a mistake when we're working with fractions. Let's do one more for today. Let me sort out this pile of integrals. Go. Okay. Oh, what the heck? These variables need to match. There we go. So we need to rewrite this so that it's in the format for our rule. So we have that 4 and we have the 5th root of w cubed.
So it'd be 4w to the 3/5.
Right, exactly. So that 5th root gives us the denominator of our exponent, and then the cube stays as it is. So our n in this case is 3/5. N plus 1 is now going to be 8/5. And so that's our new exponent.
So would it be 4W to the 8/5?
Yes, 4W to the 8/5 divided by 8/5. So we're raising our power by 1 and dividing by that new power,
Oh, and 8.
which really means we're multiplying by the reciprocal of the new power.
So 28 W 8/5.
Yes, we do need to reduce the fraction, and so you can do it after multiplying or before multiplying. I prefer to reduce before. So that will actually be a 5/2. So we have these three like sort of basic integration rules at the moment. We have our opposite of the power rule, which is what we're doing here, raise the power by 1 and divide by the new power. We have our E rule, which is just the same as derivatives. And then we have our natural log as well. And so we're going to be building on our integration skills next class as well. So the beginning of class on Thursday, up to 20 minutes will be for questions for the test. And then we'll continue with chapter 5 after that.
Perfect. Thank you, Madeline.
Yeah, thank you. See you all on Thursday.
Have a great day.
You too.
All right. Bye-bye.
Thank you.
Welcome.